Muy buenos días a todos. Nuevamente les doy la bienvenida a esta nueva jornada técnica de las aplicaciones del hidrógeno. En esta oportunidad vamos a conversar sobre el uso del hidrógeno en la generación de calor. Su uso potencial está en los sectores industriales y a futuro en un sector residencial. Por eso creemos que es muy importante conocer los nuevos desarrollos, así incorporarlos dentro de nuestro portafolio de conocimientos. Pero antes de empezar, quería mencionar a nuestra contraparte, el Ministerio de Energía, que apoya la organización de estas charlas, así como nuestros colegas de la Asociación Chilena de Hidrógeno HO Chile, Universidad Técnica Federico Santa María, el Centro UC de Energía, el Comité Solar de Innovación Energética de Corfo y a la revista Electricidad. Sabemos que los aspectos técnicos del hidrógeno son uno de los más importantes, que por cierto es el objetivo de todas estas charlas que estamos haciendo, pero nuestras acciones abarcan también otros tipos de aspectos como el financiamiento de estudios relativos a la normativa del hidrógeno que estamos apoyando al Ministerio de Energía, así también con la identificación de impactos ambientales que estos posibles proyectos podrían tener en un futuro, y la generación de empleo de que este nuevo mercado traería. Eso es muy importante también porque el hidrógeno queremos que sea un desarrollo local. Y además, como comenté al inicio, hoy nos enfocaremos en en la producción de calor mediante calderas con hidrógeno. Solamente como un dato, en 2017 se estimaba que en Chile había más de 10.000 calderas en el país, las que se utilizan para la recuperación de calor en forma de vapor y agua caliente o calentando fluidos térmicos. Además, las calderas son utilizadas en distintos sectores: industrial, comercial, institucional y residencial. Y si bien es cierto, las emisiones individuales de cada una de las calderas puede ser pequeña, pero las emisiones totales de todas estas calderas sumadas son significativas. Entonces aquí es donde aparecen los nuevos combustibles como el hidrógeno, y es por esta razón que nosotros contactamos a la empresa Bosch, la cual desarrolló una caldera que está preparada para usar hidrógeno. Para presentar y explicar este nuevo desarrollo es que tenemos los siguientes expertos. Felipe Guerrero es gerente de ventas del Cono Sur en Bosch Thermotechnology, es responsable de los sectores de venta y negocios en el área comercial, público e industrial, así como en el área de calefacción y ventilación y agua caliente y calderas industriales en Chile y Argentina. También la presentación del tema de hidrógeno nos comentará el experto Daniel Gosse, que es el jefe global de marketing y academia, soluciones comerciales e industriales de Bosch Thermotechnik Alemania. Y ahí finalmente, a cargo de las preguntas y respuestas, estará Matthias Reich, el cual es el gerente de desarrollo de las calderas industriales en Gunzenhausen, en Alemania, y es el responsable del Departamento de Desarrollo Mecánico y Eléctrico de Calderas Industriales. Como en las versiones anteriores, la presentación principal será en inglés, así que por favor hagan las preguntas por medio del chat. Todas son importantes, no se queden con ninguna, y nosotros iremos recopilando y vamos traduciendo las preguntas para que al final de la presentación Matías pueda contestarlas. Así que, por favor, ahí el chat está para ustedes. Pero antes, como a modo de introducción, Felipe nos dará la introducción de Bosch, cuál es el alcance de la empresa y cuál va a ser la temática de Bosch. Así que, Felipe, por favor, tu cámara encendida, micrófono y la pantalla es toda tuya. Adelante.
Hola Rodrigo, muchas gracias. Gracias por la presentación. También muy buenos días a todos. Como dijo Rodrigo, mi nombre es Felipe Guerrero, responsable de ventas de Cono Sur en las soluciones comerciales e industriales. Y bueno, agradecer también a GIZ, ¿cierto? Y a todas las entidades y organizaciones que promueven el hidrógeno en Chile. Y también, bueno, como lo dije antes, en especial a Rodrigo, ¿cierto? Bueno, como Bosch, nosotros miramos esta presentación como una muy buena oportunidad de poder compartir nuestro conocimiento hacia el mercado, con lo que tenga referencia, ¿cierto?, en sistemas de vapor. Para eso, bueno, dentro de la agenda que mencionó un poco Rodrigo, voy a partir por la parte más corporativa, ¿cierto?, de quiénes somos, quiénes tenemos tecnología, y también una información acerca de nuestro portafolio que manejamos en el segmento comercial e industrial. Luego viene Daniel Gosse con el capítulo de Decarbonization. Ese capítulo va a ser en inglés, de ahí yo voy a partir en español, después viene Daniel en inglés y luego en preguntas y respuestas viene Matthias Reich, quien va a poder responder todas sus dudas y consultas técnicas que aparezcan, digamos, de nuestra presentación. Bueno, el grupo Bosch hoy día está compuesto hasta los datos del año anterior, por 402.800 asociados, esto dentro del grupo, y tuvimos un turnover cerca de 77.9 billones de euros. Y hoy día, para que ustedes se hagan una idea, estamos divididos en 4 grandes grupos, ¿vale? Que es soluciones de movilidad, todo lo que tenga que ver con la parte automotriz, tecnología industrial, todo lo que tenga que ver con hidráulica, accionamiento, control y automation. Y luego tenemos Energy and Building Technology, que corresponde a nuestra unidad de negocio, que está termotecnología y también sistemas de seguridad. Y finalmente tenemos a Consumer Goods, que estarían nuestras divisiones de herramientas eléctricas y también electrodomésticos, Bien, el porcentaje de volumen de venta es un 60-40, 60 de automotriz y el 40% del resto de las divisiones. En esta slide muestra cómo está dividido finalmente nuestros colaboradores y también nuestras plantas. Hoy día, en la actualidad, tenemos 243 fábricas propias, donde fabricamos todo tipo de productos, ¿cierto?, enfocados en nuestros 4 segmentos que mencioné antes. Principalmente Europa es donde hay mayor cantidad de personas trabajando y también que lidera en la cantidad de fábricas. En América, donde estamos nosotros, somos un poquito menos, pero cada vez queremos ir creciendo, ¿cierto?, en tener más fábricas y también poder contribuir al empleo en la región. Un aterrizaje, ¿cierto?, a termotecnología. Nosotros somos un equipo de 14.500 personas que trabajamos en promover y en desarrollar ciertos productos para agua caliente, para calefacción, para el sector residencial y para aire acondicionado en los sectores comerciales e industriales también. Y hoy día principalmente nos vamos a enfocar principalmente en lo que tenga que ver con Commercial and Industrial Heating, que aquí podemos ver que está destacada en color gris en la segunda parte, donde mostramos nosotros nuestra facturación aproximada de cuánto representa esta unidad de negocio para termotecnología. Importante destacar que todos nuestros productos hoy día de la línea comercial e industrial principalmente se fabrican en Europa. Está destacado, ¿cierto?, por cada producto, donde están ubicadas cada producción. Sin embargo, nosotros hoy día la concentración, voy a poner un puntero láser, la concentración de los productos que vamos a compartir hoy día en el segmento industrial son de 2 plantas, ¿vale?, de Gunzenhausen y Bischofshofen, de donde vienen todas nuestras calderas industriales hacia el mercado chileno y también hacia todo el mercado de Latinoamérica. Una mirada de clientes referentes y un poco para que ustedes se hagan la idea de en qué clientes estamos y en la variedad de segmentos que podemos contribuir. Estamos en segmentos como, por ejemplo, papel, bebestibles, alimentos, químicas, podemos estar en minería, estamos en pesqueras. Entonces es bien amplio el segmento y la variedad de clientes que hoy día tenemos. Esto es solo como referencia, así que para que tengan una idea de dónde podemos estar. Quise mostrar nuestros sistemas y soluciones. Hoy día nosotros nos vamos a concentrar acá, ¿cierto?, en Process Heat, en Heating, y también para que ustedes tengan una información acerca de lo que manejamos en el sector comercial e industrial. Tenemos soluciones, bueno, solares, ¿cierto?, de acumulación, y también calderas en el sector comercial, como por ejemplo para centrales térmicas. En Chile no tenemos, por ejemplo, o en la región no tenemos disponibilidad todavía de los CHP, pero en un futuro se podría evaluar. Y también cabe destacar que hay una parte importante hoy día de controles y de conectividad que cabe mencionar de que hoy día están siendo muy importantes en nuestros sistemas, porque finalmente nos entregan data, hacen más eficientes los sistemas y nosotros como usuarios finales o como plantas productivas podemos tener mayor información para nuestra gestión. Por último, acá, y es una slide yo creo que muy importante, que me gustaría detenerme un minutito, es acerca de nuestro portafolio de calderas industriales, ¿cierto? Partimos en las calderas de calefacción o agua caliente sobrecalentada. Nosotros partimos en un output de 600 kilowatts en adelante hasta 38 megawatts, ¿vale? Desde la línea UTL en adelante nosotros ya podríamos configurar hidrógeno, ¿cierto? Que es el tema que nos convoca hoy día. Y aparte de eso, es importante destacar que, por ejemplo, la línea de calderas más grandes, que es la UTH o la UTHZ, estas calderas son muy ocupadas hoy día, por ejemplo, para la calefacción distrital en Europa del Norte sobre todo, así que también sería una muy buena aplicación que pudiésemos participar de algún proyecto, ¿cierto? En Chile o en Argentina o en algún país donde el frío predomine y necesitemos más calefacción. Acá abajito podemos encontrar nuestro portafolio de calderas de vapor. Partimos en 200 kilos de vapor hora hasta 55 toneladas de vapor hora, con los modelos UMB, CSB, ULS y también ZFR. Bien, lo que nosotros más comercializamos y fabricamos son las ULS en todo el mundo, y hoy día con el portafolio de calderas de agua caliente y también de vapor, nosotros ya estamos hablando más de sobre 140.000 sistemas vendidos en el mundo, y porque nuestra planta tiene 155 años, por lo tanto tenemos mucho conocimiento, mucho know-how en cómo fabricar este tipo de calderas. Y también mencionar que las calderas desde la UMB en adelante ya podríamos estar en condiciones de poder configurar calderas para quemar hidrógeno, por ejemplo. Luego está toda la línea también de eficiencia, que tiene que ver con los recuperadores de calor, que acá, bueno, acá lo estoy marcando, ¿cierto? En esta columna. Esto también está disponible para el sector, o sea, para la región completa, para Chile, Argentina y también para nuestros países vecinos, ¿cierto? Colombia, México, que ustedes pueden encontrar toda esta disponibilidad de productos, configurando, por supuesto, o pidiendo a un ingeniero de proyecto nuestro que configure, digamos, su solución. Por último, tenemos, bueno, recuperadores de calor, ¿cierto? O economizadores, que esto van en aumento a la eficiencia de los sistemas. Hoy día yo diría que podemos generar hasta calderas con 97% de eficiencia, siempre y cuando nosotros podamos configurar, digamos, todos los accesorios, ¿cierto? Y también todas las solicitudes del cliente para que esa caldera pueda entregar ese nivel de eficiencia y obviamente que se transforme en ahorro. También hay disponibilidad de hidrógeno para las calderas con más eficiencia, pero deben ser siempre configuradas, ¿cierto? por nuestros ingenieros de proyecto. Respecto a los componentes, bueno, tenemos bombas que trabajamos con las principales marcas, son muy eficientes, y también todos los accesorios de la sala de caldera que nosotros podemos suministrar, ¿cierto? Como módulos de agua, módulos de condensado y también todo lo que tenga que ver con reguladores de gas. Y por último, todo lo que tenga que ver con el sistema de control. Yo sé que algunos quizás ya conocen el PCO, que sería nuestra herramienta más ocupada, o el Make Remote. Sin embargo, hoy día nosotros hemos lanzado al mercado desde Alemania hacia Latinoamérica todo el sistema que se llama Make Optimize. Este sistema de control permite a que el cliente pueda ver y analizar la información respecto a la eficiencia de su caldera, puede predecir mantenimiento, puede predecir compra de repuestos. O sea, está todo en un cerebro, toda la información para que nuestros clientes puedan tomar mejores decisiones, incluso lleven la eficiencia aún a otro nivel. Así que eso fue por mi parte, partí por la parte corporativa y ahora por el portafolio, y ahora yo los voy a dejar con Daniel Bosse, un invitado ilustre, y también Matías Reich, quienes van a tener la mirada de la planta hacia el mercado latinoamericano, chileno, entre otros. Así que, Daniel, Welcome. Would you like to start to the presentation, please?
Yes, of course. Please give me 1 second to switch to the slides. So I hope you can see my screen now.
Yes.
Yes, nodding your heads. Perfect. Thank you for the feedback. 1 second. So welcome everybody. Thank you for joining to today's session. To me personally, this topic is very important because it is our future. It's the future of our children, how we treat this planet. And yeah, before the COVID-19 crisis, you perhaps remember all of these Fridays for Future demonstrations, and our planet and how we deal with it was in the mind of everybody. I think it still is and will be again after everybody in the world has fought this virus crisis successfully. So therefore, I think it's also important to not lose this topic at the moment, because we can see the global effects of human pollution of the environment everywhere. It's alarming, the effects of global warming, and it's overdue that we react, because there's lots of technologies available that could avoid further damage to nature. Perhaps you witnessed it in the press. Bosch was one of the first global corporations who said we want to be completely CO2 neutral, and we will be so by end of this year. Of course, not completely, meaning we have to buy some certificates in order to achieve this. But even further, we have the target by the end of this decade that we will be absolutely CO2 neutral, meaning no CO2 coming anymore from any chimney of Bosch locations. Therefore, what we are also seeing, we're getting a lot of requests from our so-called key account customers, be it Mars, Unilever, Nestle, and others, who say we also want to be CO2 neutral. And even one step further, we also want our suppliers to be CO2 neutral. And this is because our customers demand it. If they have the choice and they can buy something with a good consciousness because it hasn't polluted nature, some customers are willing to spend a little bit money more on that. And therefore, I think this will be a very crucial topic to not just big companies, but also their suppliers. What are we witnessing? At the moment, global population is still increasing, and over the next decades, it is estimated to still further grow. And also, the wealth level is continuing to grow in many regions, meaning people want to consume goods. They want higher levels of mobility. They need more transportations of goods and also more production of goods to consume, be it produced foods, but also things in your daily life. And whenever you produce something, you will produce at the moment with current technologies CO2, and thus have an effect on global warming. And what we will also see is in many regions that they will not just demand more energy, but also some regions, they will demand more coal, more oil, and more gas. Everybody thinks we are going completely to renewables. That is the case in Europe and some other countries, and also with some corporations in, let's say, their African locations, because they transfer their mindset to other countries. But we see other regions like China, India, where CO2 emissions in the next decades will massively increase. They have some little highlight projects that they will communicate largely about. But if you look at these statistics, then we are not solving the problem globally at the moment. So therefore, our mantra is, you see here our CEO of Bosch, Mr. Denner, who says, words is not enough. We have to do something. Therefore, we are going this path. Even now in the global virus crisis, of course, we are also affected, especially the automotive divisions of Bosch. But still, we are cutting costs a lot, but we are not cutting costs on the global environment topics. And if you look at it, we are producing ourselves. We also are operating lots of process heat systems and boilers. Where does CO2 come from? It comes from burning gas, oil, fuels, so direct combustion, and also from indirect combustion. Because even in Germany, not all the electric power we get is from renewable sources. We still have a lot of coal and gas-fired electricity plants in Germany, but luckily we are on the path of changing this. Then, of course, before we go into the depths of the topic of hydrogen, why is this topic important for producing companies? This is because if you look, I have here the figures for Germany, but it is similar in many countries. More than 44% of consumption of energy is generated by the commercial and industrial segment, meaning nearly half of the CO2 emissions. That means we have a huge lure because it is just a few companies. If you look at the individual transportation, that's millions of people, billions even. And therefore, we have a large lure to act there and have a quicker progress. And if you look at where does this energy go, then you will see that much of it goes to applications like heating, hot water, process heat. Like I imagine everybody of you has eaten something today that was produced with process heat already. Probably you're sitting on a chair with materials. They needed process heat. We're going to work probably by car, your tires, everything needs some process heat during production. Therefore, more than 50% of the energy consumption of the companies go into thermal applications, and those create lots of CO2. Where does it come from, especially today? That's mainly fossil fuels, to be honest. And therefore, we have to differentiate a little bit technology-wise. If we look at the further slides, what are the technical options? Because that depends mainly on the temperatures we use. If we have low temperature applications, for our business, low temperature is up to 110 degrees. It's already quite warm, boiling water temperature. There mostly today natural gas or oil is used, but there are already technologies available today, like heat pumps, power to heat, electric boilers that can be used to achieve these temperatures. But when it comes to higher temperature processes, then it's a little bit more tricky. There we don't have so many technologies available. For example, we could use electrical systems, but electricity in most countries is several times more expensive than gas, for example. Taking Germany here as a production facility, we pay about 16 cents for electricity per kilowatt hour compared to gas 3 cents, meaning it's more than 5 times more expensive. And if you then have a company with €1 million energy bill per year, then of course it's a huge difference if you pay 1 million or if you pay 5 million. And that's always what we have to look at when it comes to large companies. They are doing a lot for their conscience and for their footprint, but not at every price. And therefore, the big challenge will be how to make the prices attractive for alternative technologies with CO2 neutral or at least environmental friendly technologies. Yeah, as I said, the big challenge is then the high temperature process applications, meaning above 110 degrees, up to 300 degrees and more. And this is also the area, you see it in the background, the industrial boilers. For example, they play a huge role in where we go into the pressure directive. So meaning it's also safety relevant equipment because you have high pressure, high content of water, meaning if I take our biggest boiler, if it's hot and under pressure, it has an energy content that's equivalent to 3.5 tons of Semtex explosives. And therefore, also, of course, safety is really crucial. That's why we also always have the authorities. And in this case, if we are then speaking about new types of fuels, for example, hydrogen, then of course also safety has to be maintained at any time. So what have we done in the past years? What we have done was we were thinking about, we have 130,000 boilers at the moment in the field that we have sold. These are all megawatt boilers. So that means we have a huge amount of CO2 creating products in the field all around the globe. Also lots in Latin America. We have several dedicated experts working there on these topics. And then we thought, okay, if we introduce now new product, that will help us, of course, but it won't be quick enough, because many of these boilers, I know some that are still from the 50s and 60s, and they are still working quite well. Perhaps a little bit of modernization, CO2 optimization, you see it here on the lower right corner. There are lots of options what you can do there with quite affordable technical solutions, but still we won't exchange all the boilers globally within a short time frame. Therefore, we came up with the idea, what can we do with the existing ones and the new ones as well? And we came up to the point, let me put on my laser pointer here so I can show you a little bit more. We thought, okay, what can we do? So step one is CO2 optimization. So we are also consulting large companies. We go to them. We have other entities of Bosch who take care of more production equipment and electricity, but we are really focused on heating and process heat, and say, what can we do with the existing systems as CO2 optimization? That is heat recovery in various different formats, recovery of condensate, so the used steam, put it back in the system, waste heat that we put into different sources to reduce primary energy consumption, and of course, intelligent controls. So we also introduced our digital efficiency assistant, who will really guide people through and tell them, hey, look, there's some inefficiency, you should do this and that, and guides them through the process until they solved it. And also this assistant can show people, by the way, you are using a very CO2 creating fuel, you could switch to another one and you would save this and that many tons per year. And this probably would help you. So we can have interactive consultancy within the system. Next step was we were thinking about CO2 neutral boilers. So we said, okay, you have the first customers now that have hydrogen available. The first ones were from processes, so-called brown hydrogen, but in the past they simply blew it in the environment, or they lit it up and fired it and didn't use the heat because they didn't have the safe technology to burn it available. So we said, okay, we will qualify and also modify our boilers and give the surrounding conditions and figures to people that they can fire them either with hydrogen up to 100%. We have the first boilers running with 100% hydrogen in the field with customers now since nearly 2 years. Was the first one we launched in Russia. Now we also have plants in Switzerland, in Germany, and we have different types, meaning some are running 100%, some are running a mix. We have one I will show you a picture of that's in Switzerland who uses a mix. He is absolutely relying on steam for his pharmaceutical production. And there he can switch between natural gas, hydrogen, always when it's available, and then mix those. And as a backup, he even has oil, because he says he can't afford to lose some money because his production stands still because he doesn't have steam available. So in this case, multi-fuel firing. This is all possible. We have many customers who use biogas, also biofuels. I have an example with me later, some more exotic ones from large corporations that are using it. And also in some regions, we see they have excess ethanol or some oils from, for example, fish production. And of course, it's possible to use these as well as combustible. Last but not least, here on the slide, the topic electrification. Electricity is lovely to deal with. If it's green electricity, then it's completely CO2 neutral, and you don't even need a chimney for the exhaust gas because you don't have any. And that's, of course, lovely to deal with. And then we said, how can we introduce this? We have some customers who have some electricity available, but not all the time. So we developed hybrid boilers, meaning up to 5 megawatt, we will supply heat by electricity, and we have a burner, and the customer can balance and always use what he has available at the moment. But now, the topic, of course, today, why you dialed in, is hydrogen. Therefore, I will also focus, and I will go a little bit more into detail here. And we have my colleague from engineering, Mr. Reich, in the line. So after the presentation, we will have lots of time to discuss. You can ask all your questions, and we will be happy to answer them. So let's start with the basics. Hydrogen has begun to take a vital role in many long-term energy scenarios. To achieve maximum CO2 reduction, of course, it's important to use the so-called green hydrogen. Green hydrogen meaning produced by green power, for example, from solar parks, wind parks, etc. I think it will be also important to deliver hydrogen from warm countries to colder countries, for example, Germany, and use this in the future because we have established systems, distribution networks that will have to be adapted. But basically, that's what we have been doing with natural gas over the past decades as well. As Bosch, we have realized the first hydrogen boiler project I know of, at least in the large power range, and not just research, but actual applications. And what I find coolest fact about hydrogen is, instead of CO2, out of the chimney, there comes vapor from water, like clouds, and it's absolutely clean. That's really fantastic, if you do it right. We will come to this later. So where does hydrogen come from? Basically, perhaps most of you know it, we get hydrogen from electrolysis, meaning we are taking electricity, putting water inside, we split it up, we get oxygen and hydrogen. Of course, you have to be careful not to mix them, otherwise it gets explosive. But this is a well-known technology since more than decades, it's even more than a century. Then, of course, the difficulty is how to deal with it and then burn it. Another source, available today much more, is chemical processes. So by far, the most hydrogen we are having worldwide today is so-called brown hydrogen coming from processes. And then it's available, and either you use it or you don't. Sometimes it's just waste for some companies. And we have, of course, the topic of distribution. So in this case, delivery by truck, ship, pipeline is thinkable, but the distribution of hydrogen is different than from natural gas, because hydrogen, as I said before, is the smallest molecule atom we have in the world, and therefore it can go through many materials. And if it goes through and you have it in the air mixed with oxygen, then it becomes dangerous. Therefore, you need to adapt systems and special technology. So burning hydrogen actually sounds quite simple at the first. You put in hydrogen in a burner, mix it with air, and ignite it. But the experience from us with the first few projects we had shows that it's quite tricky if you want to do it in a safe and eco-friendly way. Currently, gas grids that we have around the world are expected, they are still analyzing, to be able to use up to, let's say, 10 to 15% of hydrogen without any adaptations or only minor adaptations. But we must be aware that the heating value of hydrogen is only 1/3 of the one of natural gas, meaning if I put 15% hydrogen in a system compared to natural gas, I will have 95% of energy from natural gas and only 5% from hydrogen, because volume-wise, I have to put in 3 times as much. If I take it by weight, it's different. Then hydrogen has the highest power density. But here in gas grids, we are mainly looking at volumes. And also, I need much more air. So that is meant here with gas volume. Because if I fire 100% hydrogen, I need 3 times as much combustion air. That means also we need to adapt systems, because normally we put in one part here, one part there. In this case, we have much more throughput. Here we see it. Again, as I said, we don't get CO2 from the combustion, but we are getting H2O, pure water, if you want to say it like this. But it's also tricky to burn it. Why is it so? The flame temperature of hydrogen easily reaches more than 2000 degrees Celsius. That's much higher than for natural gas. And this can cause a thermal generation of NOx. And this means we are taking nitrogen from the air. It's 72-75% of the air, put it through the boiler together with the oxygen and what's all in the air, and then mix it, and it doesn't take part of the combustion normally, except if we reach very high temperatures, because then it starts reacting with oxygen, and then we get nitrogen oxides, and they are very harmful to the environment as well. Therefore, this is a huge topic to deal with hydrogen, burning it, that you avoid these thermal nitrogen oxides to be created. Also, it's very important to handle hydrogen carefully. I think most of you have perhaps seen it in school, cool experiments where you take a volume, something, fill it with some hydrogen, some oxygen, and then you ignite it, and there's a huge explosion. It's sometimes dealt with a little bit, too extreme. For example, if you would take a glass, put in a few drips of fuel, the normal fuel you're using for your car, on that fuel, put in air, you shake it and ignite it, it will also explode. So fuels that burn quickly. If it's more quickly, we call it explosion. But lots of fuels do that. It's handleable. You can handle that. One challenge regarding hydrogen is the diffusion. I already said it. You have the diffusion through several materials, including metals. So even a metal has not high enough density to hold back hydrogen, at least some. Therefore, we need to use special materials for hydrogen. And also some metals react with hydrogen and they get like stiff, you get embrittlement, and then if you add force, they will break. And that's also important to look at. I told you before how much energy you have in these boilers. If you get embrittlement and suddenly there's an explosion, I could show you pictures from other countries, not our products. I won't tell any names, but where you really have severe accidents and the whole factory collapses. And we just saw in media yesterday how big explosions can get. Of course, this was extreme in Beirut, but also boiler explosions are really severe. I've seen really horrible pictures from especially also India, where they have several hundred people injured or dead every year. Of course, not with our boilers, and of course also not with other quality products, but nevertheless, it's a serious topic. Okay, what are we doing then to solve these issues? We have to introduce measures against nitrogen oxide, and we also need to introduce soft ignition measures. As I told you before, burning quickly, if it's a fuel that burns quickly, the more quick it is, the more likely we are used to call it an explosion. So soft ignition means we need to smoothen this process of the ignition in a safe way, and then everything's fine. As soon as the flame is burning, everything runs normal. Also, of course, we need special gas ramp materials, and also the same for the distribution. What we are talking with customers worldwide a lot is how and when will they have hydrogen available. So in case you are interested in using hydrogen in the future to reduce or eliminate your CO2 emissions for your process or heating system, we thought of different options we can offer, because not everybody has 100% hydrogen available now. And therefore, we came up with the option to say, okay, let's make our product hydrogen ready. And I think other manufacturers of other products are thinking in a similar way. So you buy a boiler, for example, today, you're going to use it for the next 30, 40, 50 years. You want to be flexible. Perhaps like look at the Netherlands, they are prohibiting new systems that use natural gas. They had some troubles locally with their own gas sourcing. Nevertheless, you can come in a situation where something like that happens. Then you are in a position with a boiler system that had cost you several 10,000s or 100,000s of dollars or euro. And then, of course, you want to keep using it. You need it to run your production. So therefore, you said, okay, we need to have modernization options for CO2-friendly fuels. We need to make and certify our products hydrogen ready, meaning you can transfer them to hydrogen later, or you can order them hydrogen firing immediately. But this is, of course, expensive. It's an investment in the future. So we said, okay, let's put the big part of this investment, the combustion part, in the future, but prepare the rest of the system and all the installations and surroundings, because that's also expensive, of course. But if you then later can upgrade it, then that's the best option where you can flexibly choose your fuel of the future. One thing that you have to think of to have boilers hydrogen ready is oversizing the system. I told you, like, you need 3 times as much gas running through the boiler, and this is here the case, and therefore you need larger volumes. You can say roughly 10% higher throughput, or you could reduce your maximum load a little bit, try to regain some energy from waste heat recovery, so you can compensate it to keep and maintain the maximum performance of your system. And of course, you need to be flexible to include some options for the nitrogen oxide reduction measures, because of course otherwise boilers lose their certification, at least in Europe and most other countries. The question I get a lot from customers is, can I mix hydrogen in my current system? We are in contact with, of course, all burner manufacturers. They also produce some burners, especially to our specification. So, for example, for here Dreitzler with Marathon, we have just one example. We are not exclusive there. We have the case that we can mix up to 2% of hydrogen with the existing systems without major adaptations. Minor adaptations, and even up to 5% is possible with some minor changes, meaning we would have to retrofit in combustion control, mainly oxygen content based, so measuring the oxygen content in the flue gas and then adapting the fuel-air mixture, and that can compensate for a lot. Also saves you some fuel. What if we want to add up to 10%? Then we have to do a little bit more. We would have to readjust the burner, put a service technician there. He has to look at the extreme points of operation, meaning with the maximum amount and minimum amount of hydrogen, and then we can adapt it. When it becomes tricky is if we take more than 10%. Then we need major adaptations because of the topics I told you before, and also we need a new certification, because it's, I told you, safety relevant equipment. And also the notified bodies will ask us to do so. I got for you some exclusive pictures, we have not published them anywhere else yet, of an example of a hydrogen burner. This is a multi-fuel burner, of course, a nice Bosch boiler, and it uses as well oil as also natural gas, here in yellow, and also hydrogen as fuel. And here we are mixing it. In this case, the customer needs to be flexible. He has discontinuous amounts of hydrogen, meaning he has to adapt the amount. He has the external recirculation here because he needs to have very low NOx emissions, nitrogen oxide, and therefore he has to put in some exhaust gas in the burner to cool the flame and make the nitrogen less reactive with the oxygen. And if you look at here, we pull the burner out of the boiler to give you a very detailed view inside. And here you can see it's a very complicated technology, and we also have to have several different burner heads at the same time that are working independently. And then we need the control technology to align them again so we achieve the values we want. Here's another picture, a little bit more in detail. This is one burner manufacturer that we work with on hydrogen. We are working with 3 manufacturers mainly, meaning Dreitzler, Elco, and Sake, depending on the application. And then we engineer together with them the system that we attune it, that the set specification parameters in total are working. I also have some breaking news for you. Just yesterday, I got a confirmation on a nice project we have in Germany in the community of Wunsiedel, not very well known, in Bavaria. It's very sunny here, as you probably can see out of my window. And there they installed a power to heat, a power to gas installation together with the company Siemens that produces up to 10 megawatt of hydrogen. And it's green hydrogen from solar electricity. And yesterday we got the confirmation that we will be lucky and will deliver a 5 megawatt heating boiler that can accept up to 100% hydrogen. So they will have a green district heating for their community. Sorry, I had to drink a sip. I would like, before we go into the discussion, to show you also some information on biofuels and electric alternatives, because hydrogen availability will be a topic to be solved within the next, let's say, decade, 2 decades, and we need some alternatives already now, or a mixture. I will keep it short for you, but I think it's an important topic. So biofuels, what do you mean? What do we mean with this? I mainly mean liquid or gas type biofuels. Biomass, it always depends a lot on where you get your biomass from. If you take trees and cut them down, that's CO2 that's long-term bound, and you put it back into the air, meaning you have a negative CO2 effect. If you have biomass, which is like waste that would be digested by bacteria very quickly, then this would put again CO2 or methane in the atmosphere. So in this case, it's CO2 neutral in the mid-range if you burn it or if you leave it to the bacteria to digest it. So in this case, it's a little bit more complicated. I will focus today absolutely and briefly only on liquid and gas type fuels. We have there, for example, bioethanol, methanol, plant oil, animal fat. We actually have projects with that, also close here to our factory, where they put dead animals you can't eat, and then there's lots of fat coming out of them, and either they pay a lot of money to get rid of this because it's a special disposal, or they use it and burn it and treat the exhaust gas so it comes out in a clean way. And that's the same also for a lot of fish factories, so as fish oil. And also we have biogas, of course, with the waste from agriculture, and sewer gas. And there, of course, it's recommended to take special burners. For example, for the liquid types, we need a burner with a centrifugal tumbler, meaning it rotates very quickly, distributes the fuel in a very fine way. So we have a very good combustion, but it doesn't get clogged up, because normally you would put it through nozzle that could clog up because you sometimes have particles inside. And that creates then inefficiencies, and also tends to, it must be serviced. You have to downtimes for your system. For the gases, most of them, they have lower heating values than natural gas. You have to, again, put more gas and air through the systems. And of course, you should use a combustion controlled technology. I'm almost through with it, just showing you how such a system could look like, because we design every boiler depending on the application. It's like, I don't know any boiler that has been produced twice here. In this case, it's in Denmark for the company Vattenfall. It's a huge energy company that produce electricity and district heat. And there they have a plant oil. And the topic is that it is clogging up the system because of the combustion that's natural with this fuel. They have to clean it, and they had to clean it up to 3 times per day, because they want to get the heat transfer surfaces clean again, because only if they are clean, they work efficiently. Otherwise, they use lots of fuel and have a high exhaust gas temperature. In this case, they use, as I said, a rotary atomizer, so a rotating cup burner. And here you see all these lines in the front of the boiler. There they have pressurized air and fully automatic cleaning, because you can't open the boiler, clean it 3 times per day, let it get cold, heat it up again, and so on. That creates inefficiencies. And here the efficiency is not as good as with natural gas, but still 93% is huge. If you compare it in the US, many boilers are running at like 84%, and they're proud of it, but it's always a question of how expensive your fuel is. And so this is a very good value, considering also it's without condensing technology, meaning exhaust gas temperatures roughly at 130 to 150 degrees. With condensing technologies, we achieve lowest temperatures coming from 1700 degree of combustion down to, let's say, 58, 57, 59 degrees Celsius exhaust gas temperatures. So we are really using all the energy. Before I finish, let me show you a quick glance on electrical systems, because green power can also be used directly without transferring it to hydrogen, if I have it locally. And here we can implement electric coils inside the boiler, in this case up to 5 megawatts so far, probably later some bigger ones. And if it's green electricity, then of course this will be CO2 neutral. When do people do this? One reason is they have very cheap electricity prices, of course. They use it also for warm keeping, to not switch on and off the burner all the time. When they have excess electricity, because they have local electricity production and they don't get a lot of money when they put it back in the grid. And also for network stability. So sometimes they get some benefits from their power company if they consume in a continuous way. And then, of course, such a heating element can be an important factor to realize this, because the boiler is very flexible on which fuel he is using. Last but not least, of course, if you are producing electricity locally, it's rather a combustion engine or a turbine, and then you have exhaust gas from them. This is very hot, and you can still use this energy. There it's possible to use, for example, a full waste heat recovery boiler for exhaust gas. Also just use it partially here, introducing it in the 4th pass of this 3-pass boiler plus the 4th pass, or also using it instead of a burner. Of course, this is kind of CO2 neutral because the exhaust gas was already generated. You don't create additional CO2. And you can save lots of energy with it. Our typical applications are behind engines, behind gas turbines, also in glass work, so production of glass, steel mills, steel production, and cement factories. Finally, but I will keep this very short, optimization of existing boilers. If you look even in a high-tech country as Germany, 83% of all boilers are inefficient because they are very old, average age between 20 and 30 years. And there's lots of opportunities how to save energy there, be it on heat recovery, switching the fuel, also of course to hydrogen, by better controls, better optimization of the burner, saving electricity, water treatment, using condensate, and several other options. But that shouldn't be the topic here today. The coolest thing about this is it's quite cheap, it's known technology, and the return on invest on these topics is usually between 1 and 2 years, so much quicker than a complete renewal of a huge system. Last but not least, a curiosity. What I came across within the past years, that is, you burn a fuel, it comes out of the boiler as CO2, and then you reuse it in the processing. So I won't tell any names, but if you look at the right, for example, I know a very well-known beverage manufacturer that is available in all of your countries, where you have carbon dioxide, so the nice sparkle, that comes from cleaned boiler exhaust gas. It is cleaned, it's completely pure. That's the nice thing compared to also other options to produce it. And they put it back in the bottle, so they don't need an additional CO2 source, because they said, we already have a CO2 source, you just need to make it consumable. Also, for example, instead of the gas, when you have, for example, milk powder and the you have, instead of air, another gas inside, so it doesn't go into oxidation, then this is an option. And in colder countries, when you grow stuff in a greenhouse, they saw if they put additional CO2 in the air, that the plants are growing quicker with larger fruit, and therefore they introduced clean boiler gas into the greenhouses. They do this a lot in the Netherlands and also in Russia. So summing it up, finally, before we go into the discussion, already now 20 to 30% increase of efficiency in many existing systems are possible. So I always encourage customers to look at that, even if it's not our main business, but just for the sake of environment. You can also prepare the systems there for different alternative fuels like biofuels, etc. Some fuel companies will have hydrogen available, and if they have, then of course it's an option to burn it and just get water instead of CO2. Or if you have it from green power, think about introducing electric systems, perhaps also as a combination. During the day, electric operation when the sun is shining, at night use the hydrogen. Then you have a very much higher overall efficiency. So therefore, I see hydrogen as a major fuel in the long term of process heat and heating, and also the topic of synthetic fuels that are generated from hydrogen in order to make it easier to transport, to use, safer to handle. So in my opinion, my personal opinion, it will be an essential topic for the factory of the future, for the mobility of the future, and even in our personal lives, but this will be in the long term. The biggest effect for nature, CO2-wise, will be if we introduce technologies like these, first for commercial and industrial applications, because the number of participants we have to reach in order to have a huge effect is much lower. Technology is available and also much more affordable. And in many countries, they also get subsidies for it because governments have their own CO2 targets and want to help companies to realize it. Therefore, my recommendation, check your existing systems. You will be surprised how much part of your CO2 footprint actually comes from process heat and heating. Check for subsidies. Perhaps you get innovative technology for free or subsidized. Check which fuels will be available in the future and make your systems ready for the future already now. Prepare for it. And of course, subsequently, if you have something available, introduce it because your kids will be thankful for it. I have one on the way at the moment as well myself. And so I'm thinking about what his, to be exact, her future will be. And I want for her to have a clean and safe planet. Yeah, therefore, this is also a really personally important matter to me. For Chile, we have also prepared a takeaway. And here, the recommendation is not just subsidies, but also look for pilot projects. Look if there are advantages for you, for your customers. Look, for example, for pilots in the mining sector or other examples with industrial boilers. Be part early, because if you are early in, you might be part of a huge industry of the future. And try to shape the norms. So if there are norms and you can work on them, they may secure your business of the future because they will be market entry barriers for your competitors later. Also, of course, transfer your knowledge, share your knowledge, and try to grasp knowledge from other sources, other countries. Look to Japan. They are very long already working on the topic of hydrogen. They are using it even in the personal sector already. And hydrogen is a competitive factor. If Chile or another Latin American country becomes a major supplier of hydrogen on the market, I think this is an important topic for the future compared to, for example, rare earth in the earth for mining or something that's somehow limited. Green hydrogen is unlimited. You need water, you need sun, and it's universally applicable. Therefore, in my opinion, technology of the future. If you need support from our side, you can, of course, contact either me, also via LinkedIn or colleagues in the line. And in case you need information, also in Spanish, let us know. We will deliver it to you, configure your system, and try to offer whatever is needed in your pilot project, in your actual own application, or if you're just interested in how your system could look for the future. We have our contacts here. You can, of course, take a screenshot, or, of course, look on LinkedIn. You will find us, Daniel Gosser. I think many of you are already following our channel. Last but not least, just to give you an outlook, we are not just looking in the industrial sector at hydrogen. We are also running field projects. For example, in the UK, we have there field examples of small hydrogen boilers, also for the public sector, for the own personal use, also for the hot water systems for homes. So I think in the midterm, also hydrogen grids will be available, especially in pilot projects across Europe. UK are very intensively working on this. This will be very exciting times. I will close now my presentation. I will be available for you together with my colleagues for questions and answers. And I would also like to hand over to them now.
Okay, thank you very much, Felipe and Daniel. Excellent presentation, very detailed. Good data, etc. As we saw, the possibility of reducing emissions in the industry are becoming more concrete. Yeah, and in the future, the replacement of conventional fuel heat system with clean fuels such as hydrogen is already a reality, you know. And 3 years ago, we saw the hydrogen cogeneration was possible. And today, Bosch showed us his progress in industrial boilers. I think we will soon have more and more news about the residential boilers. Very good. Now we have a lot of questions today, and we will start with the question and answer with Matthias. Thank you, Matthias. Let me check the answer. Okay, the first one is can you explain the technology behind the burner that used hydrogen inside the boiler?
Yes, hello from my side. I'm Matthias Reich. I'm from Gunzenhausen. The technique is, let's say, nearly the same as we have it with the normal gases, but we have some specialities. Daniel Gosse already described what the problems are, what the challenges are. The biggest challenge is the explosiveness of hydrogen and the very fast ignition of hydrogen. And for this, we need a little more intelligence on the burner management system for this. So we have the biggest difference is in the management of the fuel. Besides all the things of the materials and so on, Daniel already described.
Okay. Could you comment about the acids or components that can be generated by the hydrogen boilers? How is this handled, and how could the impact of the availability or working time of the boiler? And in this sense, which material are used for hydrogen containers or industrial burners?
You said about the reliability of the system?
Yeah, because when you introduce hydrogen, you introduce a new fuel, and this mix and produce a chemical reaction different to use only gas, and that maybe can produce other problems, for example.
Yes, for sure. It's a new technique, even if you are burning 100% of hydrogen. If we are talking about the mixture, that's not a new technology. We all know about, in former times, we call it town gas, which already includes a lot of hydrogen. So we have a lot of experience from the past dealing with hydrogen. The new here is if we are talking about 100% hydrogen. That is the target. So we have experience from the past, and we have to adapt it to the specialities of hydrogen. The burning fast, the very explosive ignition, that's are the points we have to deal with. We have to use special materials. Most of them, they must be more temperature resistant as the normal materials. So we must need special materials. Stainless steel, thermal resistant steel. So that are the points. But if the system is running, that's the point Daniel described, then everything is fine. The critical situation is hydrogen is always the ignition. We must bring the system running with a smooth ignition. That's the target, and that's the point we have to deal with. It's always the point of the ignition. It must be smooth.
And perhaps to answer the question, if I may add, regarding acids, it's different. If you look at, for example, high fuel oil or something, you have sulfur inside, and then there's combustion. Sulfur oxide together with water creates acids. That's a well-known problem. If you put pure hydrogen and air in the system, then there is nothing that creates then this acid. The only chemical reaction that is not only new, but in addition, that's the one with the nitrogen at the very high temperatures I explained. And there's not an acid that's the problem, but a gas that's not good for climate. But there are well-known technologies like flue gas recirculation that enable to reduce or eliminate almost these effects.
Yeah, I think that the following question is related with that, because you mentioned in your presentation you used biodiesel, or you can use biodiesel. And some question is, are there any technical restriction of the use of biodiesel obtained from used oils and transesterification process in your boiler, or different kind of biofuels or from different sources?
The point I see, if we talk about biofuels, then there are no norms for the biofuels. So we have to look at the content, what is inside of the fuel. So it's always different. So we get different oils, and we have to think about what is the content and what are the problem content inside. And then we have to adapt the burner system to make a secure system, because then we have to deal with the problems of acid and so on, sulfur content and other things which could be inside, chlorides, fluorides. So it can be the variety of the different fuel is very big. So the main point is biofuel is not normed, and we have to make it tailored to the content of the fuel. And that makes it difficult.
It's a good point to consider, yeah, especially in the norms. In Chile, we have many industrial and residential boilers that are really, really old. Can you tell us about the limitation of doing hydrogen upgrade to all boiler, or it can be applied to any boiler, even though it's old, for example?
For our boilers, let's say for the industrial sector, we can say a mixing of about 2% of hydrogen is not critical. But if we have higher contents of hydrogen in an existing system, we have to have a detailed look. That's for our system, in industrial systems. For the residential systems, I think they are on a similar way. But as far as I know, there is no final statement for this. In Germany, I know there are a lot of working groups dealing with this issue, but I don't know, but I don't see at the moment a final statement for the clients. For the industry, we can say the 2% is safe, and for higher contents, we have to look. And up to 5%, normally we can say up to 10%, it can be done. There must be a visit of a service technician at site to check the new combustion situation. The main problem, if we talk about mixture of hydrogen, is the fluctuation in the net of the fuel. If we can mix the system or hydrogen from 0% to 10%, then it can be a problem, even if we are dealing with existing plants.
Okay, and the next question is related to some commercial. It's an opinion. What is your opinion? Because what is your commercial? What is commercially more viable today? Converting a coal or gas burner to hybrid, or to burn full hydrogen? It's like a tricky question.
You mean from the commercial side?
Yeah. In your opinion, what makes more sense, to pass to hybrid or to fully hydrogen burner?
I think the problem of hydrogen, as I see it, is always the availability. If it's sure that you have 100% hydrogen always available, go with hydrogen. But as far as I know, there is an availability problem. And normally you need a backup. So a 100% hydrogen burner itself without any backup, I don't see at the moment. There's always natural gas as a backup.
Yeah. And other question is related with the use of electricity to burn or to heat up some liquid, etc. How does hydrogen compete with electrification? When green hydrogen uses electricity as an input, it always be more expensive than electricity. Or it's difficult to electrify high temperature boilers? What is your opinion? Because we produce hydrogen from electricity and convert again, or the hydrogen has the possibility to reach high temperatures. This is the advantage. What is your opinion?
for me, it's a question: what is the situation for the client? How does he get the electricity? Does he have the electricity? So if he has the electricity for nothing and he only has to use it, then put it in the boiler for sure. But if he has to buy it, then I think it doesn't make sense.
Somewhere are asking about the burner. A burner of diesel fuel, typically you can see the flame into the boiler, but if the flame of hydrogen is not visible, and then how can lead with that? I think I referred it to visualization of the flame in order to check the functioning of the boiler. You know that you have a little space to see the flame. What is in the case of hydrogen is not visible.
Yeah, that's not really a problem. That's not really a problem, because our service technician, yes, they are looking inside of the flame tube with their flame hole, but normally they don't rely on their eyes. They rely on their measurements. So they are measuring the flue gases and the content of CO or CO2, and then with this information they are adapting the firing system. They not with their eyes. That was technique from the past, let's say. Now we have measuring systems, measuring technique to make it sure and make it safe. Yeah, they make a controlling with their eyes, but not only a controlling, and to get a feeling of the flame. So if you talk to them, they say, okay, they rely on their measuring technique and not on what they see in the flame hole.
Yeah, I think it will be a cultural situation.
For sure.
Here.
Yeah.
Okay, and when you produce green hydrogen, you are producing 8 kilo of oxygen per kilo of hydrogen. If you use that oxygen to burn in the boilers, there is no need for air, and no NOx will produce. We can use in this way.
To be honest, I never heard about such system in an industrial size. I know there are some experimental things, plants dealing with this, a combustion of pure oxygen with pure hydrogen, but not in an industrial size. I don't know any of this system in a bigger size. So I don't see it at the moment. I think the technique will be much more complicated. I think that at the moment with 100% hydrogen.
I think the question is related with the use not air, to just use oxygen to avoid the NOx to produce it. Yeah, I think that.
Yeah.
Other question is, can you explain more about the soft ignition? Do you use different methods than electric spark for the ignition?
Yes, we saw the picture. One thing is that we saw some nozzles. There were a lot of nozzles, if you remember the picture. And the first thing is that we divide the gas flow into different nozzles. So we ignite not a very, let's say, big flow. We ignite several smaller flows on one side. On the other side, then we must purge the nozzles before ignition. A purging will be done with N2 Stickstoff.
Nitrogen.
Nitrogen. Yeah, thank you. So that's a purging before the ignition, so that it's safe, that there's no hydrogen left in the nozzles. And with these measures or with these devices, we are sure that we get a smooth ignition. So the division of the fuel on one hand, and then the purging with nitrogen on the other hand. So it needs more intelligence, let's say, for the burner management system. So it makes it more complex, more difficult, and more expensive for sure, unfortunately.
Yeah. for existing boiler that burn coal, and there is a possibility of producing hydrogen on site, what will be your recommendation as business model, for example?
Wow. Don't really have an opinion.
Yeah, because I think it refers to produce the hydrogen on site in order to burn other things. Maybe for example, in your the project you are planning, what is the requirement of the client to produce hydrogen on site, or to bring hydrogen from trucks, etc., from Linde or Air Liquide, etc.?
I think at the moment we have the only two possibilities: is bring it by truck or make it or make it on the plant itself. I think for the future we only have the possibility to make a hydrogen grid, to bring it to all the plants. That must be the future. That must be the target, as we have it with the natural gas at the moment. We have a grid over the whole country. So, but at the moment we are not in this situation. So we have only the possibility to make the hydrogen on site on the plant. Perhaps it's a bigger industrial park where a lot of countries are there, and they can share the hydrogen, and then the possibility with the trucks. But normally this is not really a possibility because of the amounts of hydrogen you need for the bigger systems.
Yeah, you know, in Chile we have sites or industrial site at very high altitude. And how does this type of boiler react to this geographical altitude, for example?
There's no difference to normal burner systems we have. So we have to know the altitude, because then the air is thinner. So we need a more motor capacity on the fans. So we can calculate it. That's not a problem. That's this technique we already know, and we can deal with. That's not a problem. There's no specialty in content with hydrogen about the attitude. That's not a problem.
Okay. You mentioned on the slide appeared the hydrogen, or you are seeing the hydrogen in the long term. Why hydrogen in the long term? Is it a use of cost, technology availability, hydrogen availability, others?
I think it's a little bit of a political question, because I think the hydrogen is and must be the future. So it's the only possibility that we get CO2 neutral. So for me, it's a little bit of political question, how the politic is dealing with the clients, with the plants, to put them in the position to get the hydrogen they need.
Perhaps if I may speak a few words. Also coming back to one of the prior questions. So efficiency-wise, if I use green electricity directly also in a boiler, it's a very efficient way, because I use it and I have nearly 100% efficiency. If I create hydrogen before to burn it, then I have a much lesser efficiency, because I lose a lot of efficiency in the process of electrolysis. But I can store it, and I can use it then at any times. So when the solar energy is not available, I still can use the hydrogen. So this will be one factor. And the other one will be electric storage, because the alternative would be I store the electricity in huge batteries. But if we look at the current technologies, and I don't know huge steps there so far, these things are limited and very expensive, and also have a quite little lifetime compared to, for example, a tank for hydrogen. So this high power density is also another factor. If I look, then you couldn't put huge batteries in ships and drive them to another place and discharge them. And that's much more possible with hydrogen in the long term. And therefore, I think there will be a mix of both, and hydrogen is transportable and cheaper and in a more dense way storable. That's a huge positive factor.
Yeah, thank you, Daniel. Today or now, we in Chile we are talking about or discussing about the normative code and standards. And in the case of this kind of application, which is international standard can be used to implement of this type of technology? Can you talking about the standard security aspect, etc., about this kind of technology, or in based off your on experience, because we will need in the future to know what kind of application we have to prioritize in order to deliver or to launch a properly normative. Can you talking about the normative?
Yes, there are the fuel norms on one hand, and then we have the burner norms on the other hand. So on both sides, from my opinion, there must be included the issue of hydrogen. At the moment, the fuel norms doesn't include all the aspects of 100% hydrogen firing. So this must be done on one hand, and on the other hand, the burner norms. So in our sizes, it's the EN or ISO 676 for the gas burners. They must be adapted also for 100% firing, hydrogen firing, because of the safety issues like this ignition issue must be described and must be secured, that everybody is dealing with the same requirements and make as safe systems. And on the other hand, they're normally with 100% hydrogen, and because of the fast burning is the need of a flame arrestor. So to avoid that the flame is burning back from the burner itself downstream to the gas regulation module. So normally you need a flame arrestor. So this is one point, a very important point. It must be find a way to the norms. So there must be adaptation of the burner norms, especially ISO norm or European norm 676 for the industrial burners.
Okay, and a short question: can hydrogen be mixed or blend with liquefied petroleum gas, LPG, for example, in the boiler?
Yes, that's not a problem. That's not a problem. So we can mix it. Let's say with they have different gas ways for sure. So they can burn simultaneously, or they can burn one or the other one, or in a mixture. That's not a problem. That's burner technique, which is already existing.
Yeah, yeah, we are finally in this event, because there are a lot of questions also, but yeah, we don't have more time. But I have the last question for you, or Daniel, or Felipe. I know Bosch engineer is working with Nikola Motor Company, providing company in the truck known as Nikola 2. There are plenty of DAS components, electric motor, vehicle control unit, key components for the hydrogen fuel cell. What are Bosch's next step related with hydrogen, besides boilers and this kind of component I can mention?
Perhaps I may say a few words. We are in parallel looking at fuel cell systems, stationary ones for electricity generation, and we are already launching pilot projects. Our main focus for the pilot projects is on data centers. We have there several customers where we are implementing systems in the range of several hundred kilowatt, and they also need huge computing power decentrally, and they have problems getting the power there, and therefore that's a very attractive application for them. And there the main factor will be achieving economies of scale. For example, not using 100% ceramics, but using ceramic plated steel SOFC cells. They provide up to 60% electrical efficiency, 40% of heat generation, and don't have any NOx topics because it's at much lower temperatures. We are investigating this in parallel and already launching in the field to learn and then hopefully grow into scale. And the same technology in a different application for mobile applications, of course, when we will hopefully see fuel cell based cars running on hydrogen in the next years or decades.
Perfect. I would like to thank you a lot for you, Daniel, Matías, y Felipe. Si can, sorry, I will change in Spanish. Felipe, si tú, solamente comentarte, esta presentación puede estar disponible o nos pueden hacer llegar la presentación porque hay mucha gente que preguntó si esta presentación podía estar disponible. Si me puedes comentar.
Perfecto, sí, nosotros podemos compartir nuestra presentación, así que no debería haber ningún problema. Y los dejo a todos invitados, ¿cierto?, a que nos contacten, Chile, Argentina, Perú, Colombia, México, para ver sus proyectos, asesorar y tratar de impulsar el hidrógeno u otros combustibles y una alta eficiencia también en los sistemas. Contamos con toda la expertise. Así que los dejo invitados a todos y agradecerte, Rodrigo, y a la plataforma. Thank you, Daniel and Matías, for your participation and presentation. It's the first presentation for Latin America in this sense. So, thank you very much. Gracias, Rodrigo.
Gracias, no, y gracias a usted y gracias a todos también por mantenerse 3 minutos tarde, sorry, pero está muy buena la conversación. Solo avisarles que la próxima charla no va a ser en 2 semanas más, sino que un poco movido por el tema que hay vacaciones en Europa. Así que, y la próxima charla va a estar la empresa Cummins con Hydrogenics presentando también cosas muy interesantes. Así que muchas gracias a todos. Thank a lot. Again, see you.
Have a great day. Bye bye.